Okay, so it's 2 o'clock. Can everybody in the back hear me? Good. Okay. So everybody's here for 10:51, I presume? Because if not, I'm in the wrong place. So, okay, I'm Professor Rosen. I teach CIS 1051 here at Temple University. I also teach CIS 2168, which is data structures. The computer science curriculum consists of 3 parts in all universities across the US. How those 3 parts are divided depends on what, the particulars of that university. The first step is basically learning programming. The idea here is that we need to be able to take, be able to take some kind of program or some kind of problem and create some kind of automated solution to it. In other words, we need to be able to take our thought processes and translate them into unambiguous operations for computers to perform. That's the focus of this class. We'll be learning a lot of programming along the way to do so. The next step is learning how to organize a bunch of data, because a lot of times problems are simple enough that if we just simply figure out how to organize our data correctly, then we will be able to solve this problem. And then the third, and that's typically called the data structures course. The third course is an algorithms course, which is 3223 here. And that one's for CS majors. IS&T majors don't have to take that course. And that one specifically is for, is basically, well, what if we organize our data and we still have problems to solve? Also, how do we figure out, like, mathematically how efficient our programs are? How do we figure out, what are hard problems and how do we solve hard problems, and can we use other hard problems to solve hard problems? Also, how do computers even do math when you get right down to it? Those kind of things. So algorithms encompasses a lot. And that's kind of the core of computer science, basically a computer science education. There's lots of other things, such as operating systems, networking, the mathematical theory behind it, automata theory. There's a lot of things to it, but all those rely on this kind of core steps. Now, this course is designed for students who have basically no programming knowledge, minimal programming knowledge, or just don't have any credit in a programming course and need credit in a programming course, even though they know plenty of programming. So that's a way of me saying that the only person's progress and performance you should compare yourselves to in this class is your own selves. It's very easy to get this hardened in this class by seeing people automatically just know this stuff. But a lot of times it's because they've already had experience with this. Okay, let's see. So, can't hear me if I'm speaking. Can you hear me now on Zoom?
Yeah, we hear you.
Okay, great. Awesome. So, all right, so let's go ahead and go through the syllabus to get this started, because there's a lot of different things about how this class is going to be run, and different from last time around this class. So, and I have a basic, but it's a pretty thorough syllabus. So first things first, if necessary, we will move online. That's basic. That shouldn't happen too often. Occasionally, if I'm feeling sick, or, if circumstances require me to stay at home, or we've got an epic snowstorm that school's technically open for, but I don't necessarily feel like it's safe for various students to make a commute in, then, I'll move to Zoom, kind of things you'd reasonably expect, in general, this class is what's called a flipped class, meaning that you'll watch lectures and you'll be using our textbook material before coming to the lecture sections for practical exercises. Most of our lectures here will be spent actually doing stuff rather than listening to me drone on, because I like the sound of my own voice. I think it's awesome, but I hear it can get, quite tiresome after some time. So we'll be doing a lot of in-class exercises for credit. Labs will be held in person unless otherwise specified. So same kind of circumstance for your TA. If your TA is feeling sick, they might say it's best to, be online. These three links, you'll want to make sure you download them. You won't see them if it's embedded. So you got to make sure you download this PDF. But it's a handy reference to the Zoom link, the Discord link. We have a Discord for this class and for all my other classes. And lecture recordings are on the front page of Canvas. All right. Turning your homework is a two-part process, which is submitting and demoing. I'll go over those different processes in a bit. But basically, you turn it in and you also show it to us. Turning it in is time dependent. Demoing it is also time dependent, but less so. Your work is considered late based on when you submit it, not when you demo it. I will go over that process when I get to it. But it allows us to basically correct mistakes very quickly for you to make sure you can go back and do it and get 100 on the assignment. All right. So because I'm going over this and I'm going over it in the first thing, and I've got it in bold here, uttering some variation of the following phrase. I did not know we needed to demo our assignments to receive credit. After the first exam will be grounds for an instance F in the course for failure to read directions, which is a problem that has lethal consequences in this domain. It's not me being a jerk. It's me because I've never had to enforce this. But I just got annoyed by students using that excuse and trying to demo everything at the end of the semester. Sorry. It's not me. It's really not being a jerk. I've literally never had to enforce that. But because I have it there in bold in the front, nobody's ever had a problem with it again. So, you know. So first off, textbook. You may have noticed there's not really a textbook for this course. There is. It's free. That's why I haven't had to post it. That's why I haven't had to direct you to the campus bookstore. So you'll be signing up for the textbook at runestone.academy, and I'll be showing you how to do that in a bit. And you'll want to use the course name, Fall 2022 Rosen. That is the name of the course that will get you into the right document. When you sign up, you'll want to use your TU email address. Again, I'll go over that. Basically use your TU, whatever your number letter combination is, not the alias that you have set up. And this allows me to run a script that will basically make sure that your grades will get imported from there into Canvas. Okay. So just when signing up for office hours, ensure that you sign up with the person you want. I'll go over that in a bit. And don't cheat. Pattern detection is a subdomain of computer science. I had a really bad spring 2022 and fall 2021. So don't. All right, and finally, don't come to class even if you are feeling sick, even on exam days. If you're sick on an exam day, just let me know as soon as possible and we will work it out, okay? Because an exam is supposed to be show me what you're, it's supposed to be a representation of your understanding of the material. If you come in sick, I'm not going to get an accurate representation of that. Okay. So, right, I've kind of explained already what this course is. Discipline of computing and programming for complete novices and those with experience. So the idea here is that is multifaceted, because this may be the only programming course that some of you take simply because you are just checking it out to see if you're interested. Or you might be a senior who wants to get a bit of programming before they graduate. Or this is the first thing and as a prerequisite for 1068, right? There's a lot of different reasons. So this might be the only programming course because you only have room for that. So my goal here is to make you prepared for both the courses that are coming after this, as well as giving you enough knowledge that if this is the only class you're taking away some very useful information into the job market. Okay. This is a 4-hour credit course, so that means you should be expected for this. The general rule of thumb is 2 to 4 hours of coursework outside. I've heard 3 to 4. I've heard 2 to 4 for every credit hour that you're registered for. That's kind of the expected amount of work. This is a skill-based course. So if you practiced a musical instrument, it's like that. You have to practice. The homework is the way I make you practice. And if you fall behind, it will be hard to catch up. If you do fall behind, let me know as soon as possible so I can work with you to catch you up. It happens. I mean, it's not like there's a disease out there that can knock you out for like a couple weeks or anything. Okay, time and place, you found it. Congratulations. The lab, there are actually we have 6 different sections of students in this entire class. So basically a bunch of 30-person, 30-person sections. So depending on what lab you registered for, depending on what fits in your schedule, you'll have a different lab time and place to go to. Some students have lab on Monday. Some students have lab on Tuesday. The minority of you will have lab on Friday. If you completely missed your first lab this week, whoops, that's okay. It happens. I mean, it's also completely possible that like you just registered this morning and attended, so no worries. Just if you missed your lab this week for any reason, just let me know and I'll try my best to catch you up on it. Okay. The first week's always a bit weird. So, but you are basically required to go to the lab as much as you are required to come to class, which is that I'm not going to directly penalize you for not coming to class, but you will miss useful information and time to ask your TA information about these things. You had to have a C or better in Math 1021. This is mathematics because we do a number of mathematical operations in here, but also like the best analog that I've been able to see for understanding computer science is like, do you understand how to do word problems? Okay, so technology requirements. A reliable laptop is strongly recommended, especially since we're using an online text. If you do not have a laptop, there's a lot of options, but the important thing is that your laptop is reliable. You will suffer physically, emotionally, mentally, and academically this semester if you do not have a reliable computer. Okay. Wailing, gnashing of teeth, lamentation, torment. These are all words to apply if your laptop takes forever to do anything. That said, there are a number of resources available because I know like students aren't exactly flush with cash, So a couple of options. There's this is something that was sent out as part of the syllabus. There are ways for you to get assistance. So there's funds available. There are different resources available. There's a student technology assistant application. You can find it linked. I have it hard linked here. Also, there are if you aren't aware, there are kiosks all around campus, like on the bottom floor of Tuttleman. And I'm pretty sure in the library, where you can just simply slap your card to the machine and you'll be able to rent a laptop for a couple hours. So, and they're actually like good laptops too. If you do have like $400 or something and you're looking for a new laptop, I'll be more than happy to help you figure out what kind of, how to best spend that. That's like, and $400 is like more than enough for you to take you from freshman all the way to graduating college for a laptop. It doesn't need to be like a powerful Mac. Macs are great, but they're also extremely powerful, and you may not need as much horsepower as the Mac can provide. The only disadvantage of having a cheap laptop is the screen. You might not be able to use it outside, and the weight. That's about it. Okay. These things are only useful if you're working over Zoom, but make sure you have at least a microphone so you can talk to me if you're meeting with me over Zoom, because I do a lot of solo meetings with students over Zoom. Okay. All right. So the most important resources for this class are located on the front page. You can find a link here to Runestone, and let's go ahead and check this out now. So what you want to do is you'll want to create an account at some point here by hitting sign up. Runestone Academy is a great resource. It's got a bunch of free textbooks. And the reason I like that is that it has a lot of built-in tools, such as being able to run and execute programs in the web browser. Meaning that if you don't have Python installed on your computer, or you're like working on an iPad or something, you can still program because you can still write it on this website. It's great. So what you want to do to sign up is you want to hit sign up, create some kind of username, first name, last name. Now you'll want to put in whatever Canvas has. That's I have a Python script, which I will show you later in the semester, that basically works through the exported file of all your data and imports it into Canvas by matching you up with your Canvas data. And the way it does that is that it looks for your first name and last name to match, or it looks for your email, specifically your TU whatever the number and letters are. So make sure that at least one of those matches. Otherwise, you'll get a bunch of zeros and I'll have to go in and fix it manually. Like, it won't be the end of the world, but it will be a pain for both of us because you're going to get worried all of a second, like, why do I have all these zeros when I should be, when I did all this work? So just, it'll make your life easier for both of us if you use your name and your email here. You can make your username whatever you want though. Make your password, and then over here for the course name, put fall 2022 Rosen. That's it. You don't bother trying to make a course. Making a course, that's like a very clever move there, but it doesn't give you the answers. Actually, like for some stuff it does with the auto run, being able to see how the auto grading code executes, but that doesn't really help you unless you already know how that stuff works in the first place. And if you knew how it worked in the first place, then you wouldn't need to look up the answers. So, but anyway, point being is that you can, once you're done, once you create that, you'll be able to log in. And if you're registered for multiple courses, you'll see this. It's like fall 2022 Rosen, and this is going to be our textbook. There'll be the only thing I have to say here is ignore the chapter assessment over here for right now. Okay, ignore this for right now because this has a bunch of stuff. Like, the only problem with this textbook, this is like one of the two problems I've had, which is that over here in section 1.12.1, like, oh, did they finally fix that and hide it? Like everybody put in all their questions over there as kind of the placeholder for what chapter to put it in, and so we had a bunch of questions in the wrong place, including from the end of the book. So don't worry about that. So what do you need to do with this book? It's a big book, right? And well, I'll get into the whole formality of this, but up here we have this thing called assignments. You click on this little Persian icon, go to assignments, and you'll see what I have assigned for this class, as well as the due dates. These are very low credit and they have soft due dates. I'll get into those. So those due dates are when you should have those done by, not when you need to have them done by, when you should. Make sense to everybody? But this will tell you, hey, what do you need to read? What have you read? And what program and what kind of exercises do you need to complete? Okay. I'll go into how much that's worth in a bit, but that's how you sign up for that. If you feel like you need more resources, I've linked two free sources over here, one of which I will be using later in the semester. Automate the Boring Stuff with Python by Al Swigart. Very good book. Again, available for free online. If you do feel like you need a hard copy, guess what? It's like 20 bucks. You want a hard copy. Same with Think Python, How to Think Like a Computer Scientist. And then finally, the official Python documentation has some good stuff in there too. Although it's more, it's more directed at people who already know a programming language and are trying to use Python. Okay, so office hours. So this is fun. Office hours are actually very convenient. Now, that said, I'm still trying to figure out like when exactly my office hours are going to be. I also have to get one of my TAs to still send me their information for that. But the way office hours work, I've got an embedded page down here. It's also linked to on the syllabus, as well as right here underneath every TA, as well as myself, and it'll bring you to the same page. My office hours are conducted via Zoom, but if I have a big Zoom room open, like for 2 hours, like nobody shows up. It's a bit annoying and a bit and boring, and I'm like, gee. So instead, you can sign up for office hours. Now, these are not the only hours you can meet me with. If none of these hours work for you, send me an email and we'll coordinate a different time. These are just simply times I have specifically set aside. Okay. So for you, you would either click on general advice or 1051. Click on that, click on who you want to meet with, and you'll be able to see who's available. So right now my hours are the only, I think. So for instance, there's a lot of hours that you can see on Monday for people to meet with. You select who you want to meet with on that day, and you'll be able to select the 15-minute slot. And you'll get an email telling you, here's the links, reminding you what are the links to Zoom, as well as getting an email an hour before the meeting just to remind you that you signed up for office hours. Okay. The most common issue with office hours that we have is that students like sign up for one TA or for me, and then think they signed up for somebody else. So just be sure that you got the right person. Okay, but it's quick, it's painless, and it's really cool. It's really easy for us. You're also able to cancel these office hours if you need to. Okay, back to the syllabus. Okay, again, if you need to meet with us outside these hours, just send us an email. There's also peer tutoring available, and the schedule for that will be available like the second or third week. That's where basically it's a free service where you can meet with other students who have already taken this course and get like a lot of help with this course. Okay, expectations, we expect you to attend because, you know, you kind of paid for a class, so you might as well attend it, but also like I cover a lot of stuff in this class. That said, I realize that like life has been super chaotic since COVID. And so if you can't make it, just let me know. Right. I mean, the vast majority of you are adults, which means I assume that like if you have to miss class, you've got a good reason for missing it. Okay. Especially if you're sick. If you're sick, don't come to class. You can either watch via Zoom or you can watch the lecture recording. I record all the lectures. You can find those lectures either by clicking here in the lecture recordings or clicking here on the lecture recordings down here. Though both of those will take you to the same page, which has a bunch of embedded playlists. If you're super eager to get started, you can find the playlists for all the previous semesters. So since I've started doing these lecture recordings for this class. The start here page said, the start here page said to use spring 2020. Okay, I thought I missed one of them. I got in the syllabus in the front page, but I'll have to change it in one of the modules. Start here. Let me change that so nobody gets too confused. Here we go. Oh, 2022 Rosen. If you accidentally signed up for spring, make sure you sign up for fall instead. Sign up for fall as well. You can sign up for multiple courses with one account. So just sign up for fall. That's no problem at this point. So, okay. Yeah. Okay. So if you're sick, just don't come to class. No worries. I won't penalize you for it. Just let me know that you're sick. Okay. And that includes during exams. Mental health. If you experience significant stress or worry, you have big changes in mood, or you have problems eating or sleeping during the semester, whether because me or because of other courses, let me know. Because don't hesitate to reach out. I will look up what kind of services you need. I will be happy to listen to whatever kind of issues you have. And as far as this class is concerned, the sooner you contact me about any kind of troubles you're having, the sooner I can create like an alternate schedule for you or figure out different alternate deadlines for you. Those kind of things are really important. And the sooner you tell me, the sooner we can handle that. Okay. If you have a need of accommodations, then please contact Disability Resources if you haven't done so already. And they will contact me to tell me what kind of reasonable accommodations you need. I have yet to find an accommodation that's unreasonable. So, just go through the official channels, essentially. Right? I'll be recording my own lectures. You can record this class as well. However, the school policy is that you have to have my permission. You have to if you're recording something, you have to let me know. I'll say yes, but you just gotta let me know. Okay. So grading. So letter grades are assigned at 90 or above as an A, 80 or above as an B. In general, you need a 70 or above to pass the class. Your raw score will not be curved. However, the grade ranges will be widened. For instance, some semesters it's an 87.5 to 89.9. That is an A minus in some semesters. Some semesters 88.5 and above. That's an A minus, right? So it really just depends. I do my best to kind of bump you up. Generally, basically, the minus grades are used to bump people from a lower letter grade to a higher letter grade because that generally works out better. Okay. And we have various kind of things over here. We have solo exercises, classroom exercises, lab demoed assignments, the final project, final exams, and final exams. So that's a bunch of stuff over here. So let's go through that. The solo exercises are defined by the reading exercises I assigned in the textbook. So this is a pretty easy 10% to get in the class, just 10% points. The defining feature of these is that they are fairly short, they're targeted on specific things, and they're intended to be done with little direction, although sometimes there's a bug in the problem that prevents it from evaluating automatically. If you need help on it, ask for help or collaborate with another student, please. Like this one is like, definitely work with other people and, figure out the same answers. That's fine. These are basically meant to make sure you learn the stuff and to be able to check, do you understand the stuff? That's the purpose of solo exercises. The due dates for the solo exercises are soft due dates. That means you need to complete them by the due date if you want to stay on track and stay up to date on the material. However, there's no late penalty for the solo exercises. So even up to the last day of the semester, you can turn those in. So if you neglect to do that, get one or two students, I get like a couple students who forget that. Just be sure to, turn them in and you'll be able to get your points and I will update your score accordingly. Classroom exercises are also done in the textbook, but the vast majority of them are done in the textbook, but basically classroom exercises are exactly what they sound like. We do them in class. If you miss class that day, watch the lecture recording and do them on your own. Again, the big difference here is that most, if not all, the answers will be provided at the end of the lecture or as we go. So this is another easy 5% of the grade to get. Again, due date for these are soft. You want to stay up to date. You need to complete them by the day that they've got a due date by. However, I'll grade them and give you credit for them so long as they're done. And generally these are done for completeness. So our lab assignments are the things that are basically homework in other classes. You expect one a week. Typically they are introduced and started and substantially worked on in lab. So you'll be able to get most of it. The hope is to be able to get, for the early ones especially, most of it done in the lab. It's supervised by the professor or the TA for the introduction. I encourage you to get help from other students. Most importantly, your lab code must be demoed and explained to receive credit for the assignment. That's for lab assignments. You don't have to demo anything else. The lab assignments are what have to be demoed. So the due dates for my lab assignments are firm deadlines. Late lab assignments are accepted with a late penalty. 5 points per day, maximum penalty of 50 points. The late grades for assignments are determined when you turn it in, not when you demo it. So again, it's a two-part process, which I go over here. So, but you have to turn it in by the due date, and then you have up to 2 weeks to demo it. The reason for the demo limit is that I've had students in the past who will wait until the end of the semester and to demo everything. And that's just not fair to anybody, especially because it takes up a lot of my time. And it's generally students have forgotten everything that they need for those assignments. So it's not fun for anybody. So to turn it in, you submit online to Canvas. That way we have an electronic paper trail for it in case your computer accidentally gets barfed on by a cat. That was fun. That was a fun 2 weeks. And then you demo it your that to your TA or to me. You demo it to me during office hours, or you can demo it to a TA during the lab or during their office hours. And if you can't meet, if it doesn't work for any of those times, send me an email. We'll find time to demo it. Okay. Doesn't take too long to demo these things. Demoing it generally involves running the program and then answering a few questions that I might ask or asking you to explain bits of your code. It's not meant to be a very stressful process. It's meant to just kind of make sure that you understand what you're doing. Okay, it's important to let me know if you're struggling to complete a lab assignment by the due date, since that allows me to know whether an extension is needed for the whole class or not. If I get a lot of emails from people saying I still need more time to work on this, generally I know I'm going at a bit too fast a pace, so I'll be able to extend the deadline. So let me know if you need more time. or if I need to review it in class, or do I need to dedicate some class time to going over the bits of the lab, you know? Okay. So in general, just let me know if you're following behind. I'm not going to think any less of you. I'm going to say, okay, this is something that needs to be covered more. The final project is the climax of the course. It takes out the last month of this this course. So it is basically for the first couple of months of the course, we'll be learning all we need to do to become programmers. And then with the final project, you take that and write your own piece of software. And that is very open-ended. We'll go into it in more detail when we get closer to it. But we are very accepting of any kind of proposal you want to do. We're not particularly harsh when it comes to creating this. We're very interested in seeing what you can learn as you program this. All that we ask is you build something of interest to you that solves an actual problem, you impact campus, or you change the world even in a minor way. Strive to create something that outlives the course. So it's broken down into 4. So this is optionally a group project. So you can work into, I know some people like to work alone, some people like to work in groups. So you can work optionally by yourself in a group of 2 or in a group of 3 for the final project. Okay, the more people you have, we expect a bit more from you. So we have 4, that final project will take 4 steps, which is brainstorming a GitHub, which is we will basically figure out what ideas we want, what kind of ideas you're having, and for a final project, I'll give you some examples of good final projects. The next step will be giving us a proposal. What are you going to do? I've got a form for you to fill out for that. A progress report, which will be given like a weekend, which will be due like a week and a half before the due date, tells me, hey, that proposal you have, are you able to meet up to what you wanted to do? And if not, tell me what you need, what's changed. And then your final project. The final project and all parts of it must be uploaded and worked on GitHub. That's the only place where I'll accept it. I'll show you how to use GitHub. Don't worry about that. And the final bit that I put in, because again, this had to deal with some bad actors during a couple semesters ago. If you did not turn in a proposal by the time the progress report is due, so if you did not do this if you did not do your proposal by the time the progress report is due, which is like a week before the due date of the whole thing, I'm just going to give you a whole 0 and save us both the torment of having to deal with that, because a week is not enough time to do a final project from proposal to end, from scratch. I mean, it may sound scary, but honestly, it's a great experience for the students, where you can do it in any programming language you want. It's an excuse to also learn something that you might not be learning. Like if you want to get into games programming, it's an excuse to write a Hello World application in Unreal Engine or in Unity, which are 2 very popular gaming engines. If you want to learn how to build a basic website, it's an excuse to learn how to build a website and get credit for it. If you have a final project in another class, it's an excuse to use your programming knowledge to do that, because I'm happy to let you double dip if you get permission from me and the other professor. We are more interested in the journey you take, not the destination. We're interested in what did you learn. So it's meant to be a learning experience, not the beginnings of tech startup. The final project due date is hard because it's due on the last day of class. I can't make it due any further back than that. It will not be altered for anyone unless you've got prior approval, accommodation, or a sudden and undocumented emergency or event that happens. Like I got in a car crash kind of thing. And then you send me documents when you can, right? Otherwise, we do have a late penalty for the final project. It's penalized at a rate of 0.1% every minute it's late, meaning you turn it in an hour late and it'll be 6 points off. Try not to do that, but it's there. All right. Now, the biggest change for this course this semester is the exam process. Previously in the previous semesters, come on, it's a bit repetitive. We've done quizzes that were unproctored because everybody was like still in and out of due to COVID, and it was really hard to, proctor that kind of stuff. So, but now I'm switching back to more typical exams. I'll be trying to do 3 exams and a final exam. Now that may sound like a lot, but I'm going to try to make it a bit less stressful by doing what's called 2-stage examinations. It's a 2-part process, your exams. They'll be taken in here during the lecture. You're going to take a regular exam within the first 50 minutes of the class. The first 50 minutes is dedicated to an exam. It's going to be fair, obviously, with a 50-minute time limit. It's not going to be too long, right? It's done. This portion typically is worth 80 to 90, although we might make it for the first one a bit, less of that overall score for that exam grade. That's done alone, like you would expect any exam. And then you don't leave when you've completed the exam. That's kind of the big difference between that and a normal exam. You got to stay in this room until the lecture period's finished. Because of step 2, after the exam is finished, students split up into groups, and then you do a group exam. And it consists of either identical or nearly identical problems from the exam. That is worth anywhere between 10 and 20% of the score, although for the first one, I might go as high as 40%, just to make sure that it's good. Group size are 3 or 4. There's 1 copy of the exam per group. That forces you all to work on one either sheet of paper or 1 copy on Canvas. Why is this? Because if I gave you all individual copies, then you wouldn't talk to each other, which is what this is trying to do. I will explain the reason for this madness in a minute. But first off, as soon as you heard group exam, I'm sure some of you shuddered in terror because you probably had an unpleasant experience with groups where every single one of your group members was an idiot. That sometimes happens. It sometimes happens. I know people don't like group projects, but honestly, it doesn't really happen too much here in this kind of format. So, but simply to put you at ease, the group score cannot be your overall score cannot be lower than your individual score. In other words, the group portion only helps your grade. It can't hurt your grade. So if you get an 80 on the individual portion, your minimum grade is an 80. Even if you get if your group portion is like a 70 and your individual portion is an 80, your final grade is an 80. Make sense? So your group score can only help. And generally the group scores are not in the 70 range, but instead in the 90, 95 range. Because you'll be able to put together your answers together. A lot of the questions will be exactly the same as was on the final, not on the final, but on the the solo portion. Now, why am I doing this madness? First, it's to reduce the stress of the initial exam. To reduce the stress, because exams are high stakes by definition, and that induces a lot of stress. But also, like the first thing you do when you get out of an exam, what's the first thing you do? You go to the person who's walking out next to you that you may not even know and go, hey, what do you get for question 5? And this is kind of that process, but now we're doing it for credit. The idea here is that during an exam, that is kind of when you are most motivated to learn something you may have missed, because there's a lot on the line for getting it right. So by having this group portion, you're able to sit down with a group and you're able to point out, okay, I got most of this right. I was just missing this portion. Or I was on the right direction, but I couldn't get there. And now I'll be able to figure out how to get there. And for the people who did everything correct, you get a benefit out of this too, because the way to truly master something is to be able to teach it to somebody else. Okay, so there's a lot of pedagogical reasons for doing this. This is something that has come out of I think it was UBC in Canada, from their Earth and Atmospheric Sciences department, I believe. And it's been very well received there, and I'm just want to give it a try because it looks interesting to me. And I hope, and honestly, if we try it and everybody hates it, okay, we won't do it, but if people have a positive response to it, then I think it's worthwhile to try. Okay, further details as will the exam be electronic or on paper, and what notes are allowed will be decided on a separate, that'll be decided you know, as we get closer. I gotta figure out like how easy is it to do this on campus and that kind of stuff. So the only kind of hitch here is that if you have an accommodations for extended time or something like that, please reach out to me so we can come up with a solution for that, because I want you to be able to get as much benefit from this process as possible. It may not be feasible. We may have to arrange something separately for you. Totally fair though. I just want to make sure, but reach out to me and we'll figure out what solution works best for you. Similarly, if you miss the exam, we'll figure out something that will work best for you. The due date for the exam is hard. The date will not be altered for any reason unless you have unless you let me know. Like again, aforementioned car crash, or you're sick and you can't come in, right? In general, just let me know. Final exam, I've got to fix the link to that. I find out the day and time for the final exam, same as you. The main thing that you should know as a student for final exams is that you have a right to say no to taking a final exam if you have 3 finals on the same day. You're only allowed to take 2 a day. If you have 3 a day, if you have 3 in one day, one of those professors is supposed to be you're able to say, I need to take it on a different day. If I'm the professor, I'm more than happy to accommodate you. But sometimes professors can be jerks. If that's the case, contact the dean of students. That's what they're there for. Because again, if you're taking 2 exams on the same day, it's not fun, but it's doable. 3 exams means you're going to be exhausted for at least one of them, which means, again, you're not getting an accurate representation of your grade. Okay. Also, just note that like things are going to be worth certain points, but not all points are equal. In other words, like the homework points only go with the homework. The exam points only go with the exam points. Okay. So one homework point is not the same as an exam point. Okay. So overall, the grades for the breakdown again, final exam is worth 20% of the grade. And if we do 3 exams, each of those are going to be worth 10% of the grade. Okay. And we'll decide, and if we like this format of doing a group exam, we'll see if it works for doing it in the final exam as well. Okay. The final project is 10%. Students typically, if you turn something in that's reasonable, you tip at minimum, you're going to. My general rule of thumb is that if it amuses me for a minute, that's an A. If it's impressive, it's an A. You know, we're not too stringent about that. Oh, and one last bit of incentive for you. The best project from every section, from every lab, that group gets exempted from the final exam. That is your incentive to do as well as possible on it. Sometimes it makes it hard, you guys make it hard for us to choose who's got the best one. In which case I'll just choose both of the people in that section. So, you know, it is very possible for you to be exempted from that final exam if you want to. So that's your incentive for doing as well on the final project as possible. Okay. So last of all is the academic honesty portion. First and foremost, this big bolded part. If you're having trouble completing assignment, email me. Email me or TA. I will be happy to sit down with you and walk you through walk you through the problem or walk you in the direction of a solution to the problem. Don't go to Chegg unless you want to fail the course and receive an academic misconduct charge. Again, I had a lot of students that I've had to submit that for. But let me be clear on what I consider reasonable and what I consider unreasonable, because I do want you to collaborate with people. Okay. When in doubt, ask me if it's allowed. Okay. So, and I'll be honest with you, because I know that sometimes it's a bit hard to understand some subtleties where something might be good or not good. First off, communicating with classmates about the assignments, totally allowed. Helping a classmate identify a bug in his or her code, in person or online, such as viewing, compiling, or running that code, even on your own computer. You are allowed to have other people's code on your computer, provided it's code you're trying to help fix. In general, if you are having trouble with with a program and you want to show it to some, and you need to show it to some, you're allowed to show it to somebody else, right? If you're trying to fix something or trying to solve something, you are more than welcome to show your program to somebody or your code to somebody. Okay. The reverse of that is if basically if Alice has completed the assignment and Betsy's like, hey, can I see your answers before I turn it in? Right? That's not what's not allowed. I'll go into that. So sending or showing code you've written to someone else, possibly classmates, so they might help you identify a bug, provided you cite the help. That helps a lot for me to identify that in case there's some duplicate code. In general, if you cite what you're doing, you're not gonna get in trouble for that. Incorporating a few lines of code that you find online or elsewhere into your own code, provided that those lines are not themselves solution to the assigned problems and you cite the line's origins. Example, looking up how to print the contents of a dictionary in numerical order on Stack Overflow as part of a larger lab, then copying the said 1 to 3 lines that do that, and then citing that link is okay. How do you cite? It's not MLA, it's not Chicago, it's nothing like that. You just use what's called a comment, which is a part of the program that that the computer ignores, but humans can see. It's very easy. You just have to drop the link in there. You don't even have to put who the author is. Just drop the link. That's it. Worst case scenario, if you copy what I consider to be too much and you cite it, I will tell you to do it again. Sharing a few lines of code online so that others might help with you. So you can post on Stack Overflow for help if you've got a bug and ask them to help you fix it. Again, it's a few lines though, not like the whole program. Don't post on Chegg asking for somebody, or in Stack Overflow asking for somebody else to do your homework for you. Turning to the web or instruction beyond the course's own for references, such as the list of additional materials for solutions, but not necessarily again, trying to look for a solution for the entire problem. Doing code on a whiteboard, totally okay. Working with and paying a tutor to help you with the course, provided paying the tutor doesn't mean they're doing the course for you. What's not reasonable? Accessing the solution to some problems prior to submitting your own. Asking the classmate to see his or her solution to a problem set before submitting your own. Failing to cite those comments of code that you may have copied from online. So that means copying and pasting code you find a fight online, that's going to be trivially easy to identify. Finding code that addresses a question on exam. So this has been done when the exam was open, was essentially you were able to have your computer open, but you were limited to resources you could use. Finding code online that you think might address a problem at hand and blindly copying it. In past semesters, I had a board game that a problem on the final exam, and this was during during the whole where everything was online, and it was a question about doing a Monte Carlo approximation on this board game, which sounds a lot more technical and hard to do and intimidating than that actually is. But people would look up a Python program for that, and they'd find one, but it'd be for a different version of the game. So that was not great. Giving or showing to a classmate a solution to a problem when it is he or she and not you who's struggling to solve it. Paying somebody to do the work for you. Searching or outright soliciting solutions to the a question, assignment, or quiz exams online or elsewhere. I found a number of my questions end up on Chegg, and because I know that students use Chegg or other similar resources, there's 180 of you. If you use it, you're not probably going to be the only one who uses it, and it's fairly easy for me to figure out stuff based on syntactical irregularities. Splitting the problem set's workload. So if the problem has 6 parts, saying I'll do this 3 and you'll do this 3, that's not great either. You're more than happy to work with I'm more than happy to have you work with somebody on all 6 portions, but don't split them up in half like that, because you're not going to learn anything. All right. I think that covers pretty much of it. There's a regret clause. If you've committed some kind of offense, or you think you have committed an offense, but you tell me within 72 hours, I might say, I might impose called a local sanction, just basically giving you a 0 for that assignment or telling you to redo it or giving you a harsh penalty on it. If you tell me, what I'm not going to do is write you up. You tell me and you're honest with me, I'm not going to write you up, because we all make dumb decisions sometimes. And I like honesty. I got that bit, all this bit of this academic dishonesty, or the vast majority of it from the Harvard CS50X course, because it's a pretty great course, and I use parts of that course in here too. Also, your rights and responsibilities are over here. So, any questions before we get started? Okay. So, I'm going to go over a brief history of computer science and the field of programming with the remaining time. On Tuesday, we'll do an in-class exercise on Runestone Academy. So all you have to have prepared for Thursday is be signed up for this course and on Runestone. And then what we'll do over here on Thursday, is that we'll go over here and we'll see where we'll do some basic programming without even knowing how to really write a program. We're going to see where we can end up. We can see where what kind of actions I want to be able to teach you how to do. But in general, computer science is actually both a very new field and a very old field. It's also a bit like the Balkans, which is that there's a bunch of places that are grouped together but are actually very different from each other and all want to be their own thing, from computer science to IS&T to computer security to data science. They all kind of are extremely related to each other, but they're also very distinct. And they all kind of just get thrown under the umbrella term of being computer science, which is fine because for this course, because you got to learn programming to do all those. But it is very old. So let's see. Let me go to my file explorer. I believe I still have this thing. I wrote this thing years ago and I still use it. Okay, so documents, GitHub, teaching, ITP. Is in here. Yes, it is. All right, so I suppose we should start with what in the world is computer science, because that's kind of a bit of a question. It's not the study of computers. That you wouldn't be wrong to think so, because we use a lot of computers over here, but for computer science is not the study of computers. Actually, if I'm going to be honest, I think computer science is an awful and terrible name for this course, or for the subject material in general. There's this quote that I like, which is, computer science is no more about computers than astronomy is about telescopes, that biology is about microscopes, or chemistry is about beakers and test tubes. Science is not about tools, it's about how we use them and what we find out when we do. So computer science uses programming, but it is of itself not programming. It's more than just programming. Programming is a huge part of it, but it is not just programming. It's also not necessarily learning about programming language. Computer science, the things that make computer science existed before we had programming languages. And besides, by the time you're able to pick up, by the time you get to your to the end of your degree, if you're in the computer science department, you will be able to pick up a language in a couple of weeks pretty easily. In fact, if you decide to, you might pick up an additional language when you're doing your final project in this course. We don't study necessarily any specific software. And this all just comes from the fact that we confuse a tool with a task. So a pair of textbook authors, I really liked their definition, but I'm going to give you a caveat. You ask a computer scientist what computer scientist is, and you're going to get a bunch of different answers. But this is one that I think is not wrong. You'll have people say, yeah, that's not wrong to you. So the study of computer science is the study of algorithms. So, which of course leaves the question of what in the world is an algorithm, but it is the study of how we automate problem-solving processes. The question it asks is, what can you actually automate? What can be done automatically? And how do we measure its efficiency? So theoretical computer science, just like the heavy theory portion, covers a wide variety of topics, including algorithms, data structures, computational complexity, parallel and distributed computation, probabilistic computation, quantum computation, automata theory, information theory, cryptography, program semantics and verification, machine learning, computational biology, computational economics, computational geometry, and computational number theory and algebra. Work in this field is often distinguished by its emphasis on mathematical technique and rigor. That's just one part of computer science. So what we do in computer science when we say it's the study of algorithms is that it is the behavior of algorithms to determine, is this the correct algorithm? Is it efficient? In other words, the formal and mathematical properties. Designing and building computer systems that are able to execute programs. Designing programming languages and translating algorithms into languages so they can be put on hardware, because there's this step where we write the commands for a computer to do stuff, and then it's got to translate that into a bunch of ones and zeros. Never forget that this is that your computer processor is a rock that we zapped with lightning until we tricked it into thinking, and it's very angry about this. And identifying important problems and designing correct and efficient software packages to solve those problems. So let's see. So let's see over here. So what can you do with it besides just becoming a code monkey and doing programming for a firm of some kind and creating software, creating new apps? You can do a lot of things with it. And a lot of you in this class aren't necessarily going for a computer science degree. A lot of you are like here for a minor, or you're in biology or physics or economics or something. At Temple, Japan, which is our Tokyo campus, the vast majority of students we've had for years in the computer science program there are economics students. So a few things we can apply computer science to is biology, chemistry, medicine, bioinformatics. It's its own thing. That's the name of it. It's very big right now, and it will probably never stop being a lucrative career choice. Things and because these are the kinds of things that get studied: cancer detection and detection of new medicines, HIV inhibitors, prosthetics. In other words, this person needs a new arm. Let's build him an awesome robot arm. You know, I mean, and who doesn't like robot stuff? Okay. Also, like COVID, one of the things to come out of COVID was that folding at home became the world's first exascale computing platform. In other words, a lot of people threw their computing resources to solving that problem by figuring out how does COVID act to different proteins. Physics and astronomy. That's a fun one. Quantum computing. You probably heard that in the news occasionally and wondering what in the world is that. I'd like to know too. Supernova detection. Most of the supernovas that we are able to detect in the night sky is they're detected automatically rather than with the naked eye, but with telescopes and software. We deliver tons of astronomy data. Large Synoptic Survey Telescope is expected to gather 140 terabytes a day of astronomical data. That's a lot of data to sift through. Engineering. If you're interested in business and economics and just want to make a lot of money, high-speed algorithmic trading. That's where that's at. That's a lot of money. A lot of the big trades these days happens with software. If you're interested in psychology, there's a whole field there for you called human-computer interaction, which is how do humans interact with computers. It's a very valuable thing because at the very least you're answering questions of like, how do I keep people's eyes on my program for longer? but also how do I make it easy to use? How can I help communities that need, that would benefit from computers? For instance, I got my start in undergraduate research and therefore going into graduate research by working in the Human Computer Interaction Lab, specifically dedicated to helping the visually impaired community use computers. The kind of programs you would need, developing educational tools to help the visually impaired community and visually impaired children succeed at math. Because for some reason in the 4th grade, when graphs are introduced, the visually impaired, their scores plummet for some odd reason. Okay, so how can we create audio interfaces to kind of like solve those problems? And that brings me to the next point, education. I mean, there's a number of probably educational games that you may have had experience with. Very popular when I was growing up was Oregon Trail, and Where in the World is Carmen Sandiego. But there's a number of games that are out there that teach as well as entertain. And I mean, that's you know, if you can teach somebody something while they're having fun, that's great. So let's talk about what in the world an algorithm is. So the word algorithm comes from the Latinized name, and I apologize if I butcher this, Mohammed ibn Musa al-Khwarizmi, which was, and the Latinized name of that was Algorithmy. So he was I believe, Persian mathematician. You can look him up on Wikipedia. And he wrote a textbook called The Concise Book of Calculation by Reduction in 1820. That's the translated title. We get algebra, meaning reduction, from the title. So you can blame him for this course and for algebra. So he wrote a book containing the formal instructions on how to do mathematical operations with these relatively new Indian decimal system, In other words, base 10 numbers, and how to do operations with them. It got translated into Latin in the 1100s, and then it spread throughout Europe. Contrary to popular opinion, to popular knowledge, the Dark Ages wasn't actually, there wasn't nearly as little scientific progress as you would think, because there were a bunch of civilizations. You had, not just Europe, but you had China, you had Persia, you had India, all sorts of places that were going through different waxing and waning periods. So, and because he wrote this book on processes, we name it after him. An algorithm is a set of well-ordered, unambiguous operations which yields some result after a finite amount of time. That is the formal definition for it. So what in the world does that mean? That's a lot of words, right? So well-ordered. That means that we have a defined order we have these instructions, okay? If they're well-ordered, that means that we do them in a specific order, right? For instance, consider the recipe for building a peanut butter sandwich, right? You can't eat the sandwich before you made it. That's got to be the last step, right? The first step has got to be like getting a plate, or getting peanut butter, or getting jelly. You can define one of those, right? It's well ordered. They're unambiguous. You can't confuse the way they're done. This is important because computers are, again, it's a rock that we zap with lightning and tricked into thinking, and it's angry about this fact. Never forget that the computer is angry about the fact that you've zapped it with lightning. It explains a lot about it. All right. So unambiguous operations means that basically there's no room for like error. And like, I'm sure you've read some recipes, and a lot of recipes are algorithms that like, basically you're like, what am I supposed to do here? Am I supposed to am I supposed to cover this? Am I supposed to not cover this? That's why we use unambiguous operations. No confusion allowed. It yields some result. In other words, it does something. Okay? It does something in a finite amount of time. It's going to do something, and the universe isn't going to end before it happens. It's going to actually do something in a reasonable amount of time. Some algorithms that you may know are things like doing two-digit addition. For instance, we all have done this at some point, where basically we say, hey, here is 72 plus, 19, right? So we all have this algorithm where basically we say, line them up like this, then do the ones place, right? Add the ones place together, put the ones digit over here, carry the tens, now add the tens together, right? To get 9. We've all done this. This is an algorithm. It's just a fancy word for something that looks scary. No, sir, it's a fancy word for stuff that we already know. It's not anything scary. Okay. So now there's a lot of people that get credit for computer science and stuff, but there's some brief histories that like basis of computer science can be kind of seen in the use of the abacus, which was not a computer, it was just a very useful tool for storing data and numbers. Yes, is that a question? Oh, okay. So, but the first step towards real computation were these gear machines, which kind of were kind of like the brainstorm, very popular brainstorm things in the 1600s to 1800s. There was a lot of papers written about, hey, we could build this machine made of gears and we could crank it. And then we could use the position of the gears. In other words, how they turn to represent numbers. And then we could turn them so much to like do these operations, like adding them together. And it's not just like one person had. You had Pascal, you had Leibniz, and you had Charles Babbage, who's most well known for this, all came up with this idea. And Babbage specifically, he wanted to create this kind of gear machine that could do stuff and create a machine that it could be output on paper. By the way, if you're busy taking notes and wondering what I care about from this that I'm talking about, I care about algorithmity and you knowing about algorithmity and where the word algorithm comes from. And I care about the next name, which is Ada Lovelace. And she is often credited as the first programmer. It's very hard to determine who the first programmer is, but honestly, she's a great starting point for that. Specifically, her name is actually Augusta Ada King, the Countess of Lovelace, the first programmer. Anybody know who her dad is? Because, like, why would we care? Well, because it had an impact as to why she went into math and sciences. Because her dad was Lord Byron. If you've ever taken English and World Lit, you may have heard of him. He was kind of a rock star of the literary world of the time. And his divorce with Ada's mother was so acrimonious that people were fighting about it even after both parties were dead. That is how big a deal it was at the time. He was quite the figure. And so Ada's mother was like, I don't want any of that poetry stuff near her. She's going to learn science and math, which she did. She learned lots of science and math. Now, the reason she's credited as the first programmer after the time is that she met Charles Babbage. Babbage was designing this analytical engine. And the idea is that this analytical engine would take instructions from a paper card with holes punched in them. So what she did is that she helped translate somebody's paper that she wrote on it, but then she added in her own notes and published that. And in those notes, she gave instructions on how you could write a program for this theoretical machine that was never built to compute Bernoulli numbers, which are a specific series of numbers. Okay, so she was able to do this kind of stuff, even though the machine was never built, she was never able to test it. But she really understood the mechanics of how this machine would work. But Babbage never really got the funds to make this machine. But more about that in her notes, she was writing about how the analytical engine, which heretofore had been thought about as just being a thing you could do mathematical operations on, she thought, hey, we could possibly use this to work on things other than numbers. And that was kind of an idea that was 100 years ahead of its time. It was pretty big. Unfortunately, she died at a very early age, I believe, due to cancer. Okay. 1852. Let's see. Death. Died at the age of 36 from uterine cancer. Very early death, and it is it is tragic to think of all the things she could have discovered had she not died at an early age. The next big jump in computer science came during World War II, during the birth of modern cryptography, which was specifically using machines to break German ciphers. There were two kind of classifications: ultra, which was any kind of intelligence gained from cracking German ciphers, and magic, which was any kind of intelligence gained from cracking Japanese ciphers. If you had ultra magic clearance, you were essentially a huge asset that was never to be put in danger because you were busy cracking that kind of stuff. One of the people working on the German ciphers was Alan Turing, who you may have heard of. Alan Turing is one of the most famous computer scientists. He's known as the father of computer science by some people, due to a lot of his different contributions. But his most impactful contribution might have been his efforts during World War II and in cracking German communiques. Eisenhower said that ultra, the information they got from cracking German communiques, was decisive to Allied victory, and he estimated that without that kind of stuff, without the information they were able to gather, the World War II could have lasted for 2 more years on the European front. The similar, and by similar information, like this is the time when basically that codes had to be cracked by machines because the encryption algorithms had gotten way too complex for humans. We'll be taking a crack at some encryption algorithms later in the semester. But I mean, knowing things are decisive. We killed, the US killed a number of Japanese leaders simply because they were able to crack intelligence and know where they were going to be and know where to point the anti-aircraft cannons. It's very useful when you know what your enemies are going to do. And that kind of information, then it becomes a question of, well, how do we utilize this information in such a way that we don't let people know that we are using it? There's been a number of fictionalized accounts of Alan Turing. Most notable is The Imitation Game, which had Benedict Cumberbatch playing Alan Turing. The only thing I'll say about that is that Alan Turing was not nearly as cantankerous an individual as Benedict Cumberbatch played him as, but Benedict Cumberbatch kind of plays cantankerous individuals. That's kind of the role you hire him for. So he had a much happier life, at least working with individuals. However, the ending of his life was not nearly as happy because he also died at an early age by suicide because he was born under the horrible, utterly horrible crime of being a homosexual in the 50s. The government gave him a choice: chemical castration or jail. He chose chemical castration, and the chemicals and the resulting emotional impact eventually led to his death. The British government only apologized for the death of Alan Turing recently. The death of Alan Turing is a tragedy, and just like Ada Lovelace, it is insane to think of what could have happened to the field of computer science had they not died at an early age. So again, it is a tragedy there. So that was a great mood killer, wasn't it? So first computer, there's no clear first. There's a lot of arguments as to what it would be. A famous one though is the ENIAC. This thing, computers used to be massive, huge monstrosities that had rooms dedicated towards them. And the ENIAC, that was an acronym. It was for Electronic Numerical Integrator and Computer. The construction of it began in 1943 and was completed in 1946. It used a bunch of vacuum tubes. It was huge, 1,800 square feet, primarily used for artillery calculations. War and computing were very inseparable during the 40s, 50s, and 60s. Eventually, but the entire name of the game of computation since then has been miniaturization and globalization. IBM has introduced the first home personal computer, PC, in 1981. And then globalization, the internet, which is a global network of computers. The most commonly used application on the internet is the World Wide Web, the www you see in front of things, which is basically a bunch of documents that link to each other. The web these days is so large that it requires search engines simply to find out what exactly exists on the internet. Smartphones. The miniaturization of computers continues to this day. This is more powerful than what I'm sure you've heard. This is more powerful than what astronauts use to land on the moon. And these things will only continue to get smaller and smaller. I mean, think about it. When did the Apple AirPods first get released? Popular, completely wireless headphones. That's cute. That was like sci-fi 20 years ago. And now it's like super common. It's so common enough that people lose them. So the miniaturization is a big thing, and scale. So we are running to the end of our lecture. So the only thing I would like to say about this is that how do you become a good programmer? Practice. I'm going to give you plenty of opportunity to practice in this course, and I want you to practice. So with that, I will dismiss our first class. I look forward to working with every single one of you in the next course. If you have questions, please come up here. I'll stay behind. Thanks,